For this problem, we have the following graph here, and then we have an A, B, and C. We need to write the expression for the given interval, and it changes for every A, B, and C. And the form that we are going to use is this. It's given to us in the notes linked below the like button, so that's over there. But this is the base of the formula that is here. It's a little bit longer here, and this is because we have one point right here, and then we have another point on our graph here. This one only has this one point here, so if we add a second point, it would look like this, where we have this next part. So starting this problem off, we are going to look at A. We are given the expression from -4 to 0. That means we're going to go from -4 to 0. And when we write this out inside of here, we are going to be looking at our A. And our A is this and this right here. For every problem, it's going to be those values. So if we plug this in, we should have a t, and it already gives us a plus here, so the negatives are canceled out. This should be a minus, and then we'll have our -4, but then making it a plus, it will be a +4, and then we will have our t minus 0 here. Again, because our A is going to be those values. For the next one, it's going to be the same thing, where we have our value of 0, and it's going to 8. So we are plugging in our 0 and then our 8 to the equation. Again, this negative is part of the equation. And next we have the expression for the interval 8 and 12. So we're going to start from 8 here, and then we're going to go to 12. And then we're just going to plug these values in. And that is how we would solve this problem. Now, it's important to know where and what this comes from right here. This first part. In this first part, I'll solve for A, is the slope formula. So it is going to be y is equal to mx plus b. That's the formula, and our x is obviously t, so we can rewrite in there. But now we would just solve for this for the different expressions. Now for expression 1, I'll just solve for A. We're going to have our y, and we can plug in any point that's in our expression, but I'm just going to plug in the 120 and 0 for simplicity. So I'm going to use 0, 120, like this. So our y is going to be 120, and this is going to be equal to our m. Well, we need to find our m. Our m is going to be equal to our y2 minus y1 over x2 minus x1. That's the slope formula. So our y2 is going to be 120, our y1 is 0, and then our x2 is just going to be a 0 minus 4. So we pick 2 points for the slope. Whenever we do slopes, we have to pick 2 slopes, and this should actually be a minus -4. So we're picking the first point, and that's going to be this part, and then our second point is going to be this part. So we're finding the slope between those. And then this is going to give us a 30. And that is why our m is 30. So we'll plug this in here. Then we have our t, which is going to be 0 for this specific point right here. X is equal to t, because we can see the t is on the x-axis, and the f of t is also on the y-axis. So now we are going to have 30 times 0 plus b. Now that means that our 120 is going to be equal to b. So when we rewrite our expression, we are going to have y is equal to our f of t. We can see that based on the line we drew that up here. Y is equal to f of t. And this is going to be equal to our mx, so 30 times x plus our b, which we found to be 120. And that is how we are given this part right here. And that is how we would solve for the rest of them as well, if we needed to find that part. And that's how you do this problem. If you want more problems like this, there's a playlist in the description. And if you want notes that cover this material or other network analysis material, it will be in the description below the like button.